Anyway, closing part. Sound clear? Sound is okay? No. Charging I put. Sound okay? No. Can you hear? It is still raining here, but not very heavy rain. If sound is okay, no problem. Okay. Okay, closing part of the combined putting. See, this is the putting we considered last time. Here, see, first time what happened is, first two questions, the projection was somewhat lesser. This is more. Here, projections are more. More means not more than 2.5. Compared to span, see, if the projection is around 35% of this length, then sagging, hogging will come equal. See, I told you, if the columns are here, if this is L, for example, span L, if the overhangs are around 35% of L, suppose L is, for example, say 5 meter, 5 into 3, around 1.75, 1.75. Then this will sag, this will sag, this will hog. But as the column comes closer and closer, that is overhang increases, full will sag. That is this example. This all I told you, bending moment diagram, etc. I wrote only for reference purpose, not for explaining. Everything is over. There is nothing to explain here now. See, just the closing part of the combined putting here in YouTube today. See, 781.25, 705, 436. See, last time it was upper side, now full lower side. So complete beam, bottom steel. See, last time all, see, for this bottom steel, for this bottom steel, for this top steel, this time you need not find steel for this one. Why? When you provide steel for this one, it will come up to here. So anyway, this is lesser than these two. So whatever steel you provide for these two bending moment, it is sufficient for this one. It is over sufficient. So now 781 and 705 means what people will do? They will not go for what? Separate steel. They will go for common steel. Anyway, first we will calculate separate steel. Detailing I will give common steel. Okay, start now. So this time there is no top steel for lengthwise bending. And I told you these are all for lengthwise bending for full width of 3.25. If you want any value from here, you have to divide by 3.25. That will give you per meter strip. And then without forgetting load factor 1.5. That you should not forget. And we increase by around 25% for bending. Okay, now we decided capital D 700 and then small d we got. Check for punching shear It came safe. Yes or no? Last class, I finished check for punching. It came safe. Yes or no? Check for punching shear came safe last time. Now the remaining part. I will close this question earliest possible and tell goodbye to YouTube. Okay. Now, start. Calculation of, this will not take much time now. Calculation of longitudinal reinforcement for lengthwise bending. See, what you will do is, see here, this point is C, somewhere here column, there is a point E here. This bottom steel, we will give AST for MU equal to, see correctly now, how much? 781.25, then divide by 3.25 for per meter strip, then multiplied by 1.5, that is allowed. We will multiply by what? 125% more we will make. This will give per meter into 1.5 load factor. That much kilonewton meter per meter strip. Tell the answer. This answer you already know last time for fixing the depth. See, this MU you already know last time for fixing the depth. How much answer? It is already known to you last time. This is already, you know it last time. How much this M? This MU you already know last time. Because why? When you want to fix the depth, we wanted maximum MU. This is how you calculated. Already known last time. Fast answer. It is there with you. Other is not there because other is 705. We are not used. How much is answer? Don't waste time. See, it is started lightning also now. When the lightning comes, what happens is sometimes severe rain will come. If severe rain comes, I cannot even hear anything. 450.72. Don't give wrong value. 450.8. Okay. 450.8 I will go for. Correct? Not that I don't believe you, but safer side. Okay. Then, same way, tell what you will give steel here. This is AST for MU equal to, repeat the calculation, tell this number, kilonewton meter per meter strip. Tell this number, instead of 781.25, replaced by 705.08. Answer. Instead of 781.25, replaced by 705 point something. Answer fast. Answer. Is it 406.8? Is it 406.8? It is 406.8. Over. Now, start. I think M30 concrete, correct? Is it correct? I am not sure. Is it M30 concrete? I can't remember. Is it M30 concrete? Yes. And which steel? FE which steel? Tell me. I don't remember. 415 or 500 for this question. I don't remember. I should see the question. I can't change now because already your depth you found based on some FE 500. Okay. FE 500. Don't change the mind now. Okay. Then start. MU equal to, put the equation. Start. First, for CE portion, it is bottom steel. See, it is bottom steel. Substitute MU. 450 point, before that one do one thing. See, minimum steel, as per slab consideration is 0.12 by 100 of 1000 into 700. What is the answer? Or as per beam theory, if you consider it a beam, then 0.85 into 1000 into D is 637.5 divided by 500. Tell both the answers. Tell both the answers. This I told you. IS code has not specified beam action or slab action. So roof slab will be slab. But the foundation, even though it is a slab, it looks like a beam. So I don't like to treat as a slab. It is like a beam only. How much? Minimum steel. As per slab action. If you consider purely as a slab, minimum steel, 0.12% of BD. How much? 840. Okay. Now, instead of that way, if you consider, no. I want to consider this as a beam because 1 meter by 850, 700 millimeter is like a beam only. So, it is our version. Nobody can tell tomorrow. It is a slab. I will tell, keep quiet. Don't talk about these things. Now tell me, other answer. If you take a beam action, 1084. Okay. Therefore, do one thing. We will go for minimum of 1084. Okay, done. Among the two, higher value. So, if any steel less than 1084, provide 1084. Okay, I'll cancel. Start. 450.8 10 to the power 6 equal to 0.87 into Fy into AST into D, where is D? 637.5 into bracket 1 minus AST into 500 divided by 1000 divided by 637.5 divided by FCK 30. Solve the quadratic equation. Tell what is the AST required. Fast. Tell what is the AST required in mm square. Fast. Do not waste time. This will not take much time today. I will see the situation when I finish this one. Oh, that is the old value. I thought you gave the answer. AST required for lengthwise bending. Oh, this much time for AST required. You should do little fast, not this much delay. You are taking lot of time for calculation. By this time, you should have fluency in calculating some pattern you should maintain. When you want to find AST, after repeated calculation, see, you feed it to calculator, it will give the answer. You give solution, solve, mu equal to, write the number, AST you take x, you tell it solve, it will tell the AST value. Or sometimes people do very fast because they got some systematic approach they got. That is simplified version. 1704, okay, 1704. 1704 children badabidi is more than minimum of 1084. Therefore, provide 1704. I won't write. So for 1704, 25 torr fast spacing. If you go for 25 torr spacing for 1704 with the 25 torr spacing, this is also required. Pi by power of 25 square divided by 1704 into 1000. This also you want me to calculate. If you go for 25 torr, lot of time you are consuming for all this one. 288. No, 288 is too high. Leave it. Or if you go to 20 torr, tell the answer. Spacing. If you go 20 torr, then spacing. With the 20 torr spacing, 288 is too high. No, cancel. Why that much spacing you won't give? Because what happens is that compactness will not come. We want bars to be closer so that compactness is there. If you go 20 torr, 314, more or less than 2. Around 180, 175. Around 175 I feel. Around 175. More or less than 2. Oh, what is this? 184.32. Okay. 184.32. Or if you go to 16 torr, now tell the answer. 16 torr. Still, okay, 184.32 means you can go to 175. Or 16 torr. try. Better you bring the spacing to around 125, 130, 115, that range, so that 6 inches is closer. 16 torr. See, if you reduce the diameter, you are happy because your D is going to increase, but we won't consider it. We won't consider it now. 117. Oh, okay. 117. Or you can, okay, done. We will give 16 torr at 115 center to center. Okay. Actually, someone will tell why 115. Make it 100. Good. Close bars. Okay, done. So 16 torr at 115. So remember now, later this steel is going to be 16 torr at 115. Okay, now start E to D. ED portion. See, ED portion means right side. That is from here to here. This is your E, this is D. ED portion. Your MU is 406.8. Tell the answer. AST required. Fast AST required. MU is 406.8. Someone will tell, provide the same steel here. Yes, why I am not doing? Because today, okay, because both are almost equal, you can give same. But tomorrow it is possible that high projection is here, less projection is here. Then here you may require 25 torr at 100. Here you require, how much steel you require here, maybe half than the steel. Then you should not waste the steel. You give high steel here, go there and give lesser steel. So to understand that practically, I am not considering equal steel. When I go for detailing, I will make both equal. How much AST for that side portion? Instead of last time bending moment of 450.8, BM reduced to 406.8. Again, see, not 1530, 1530 mm square is AST required. Again, it is more than minimum. So provide directly 16 torr spacing. How much? See, when that high steel you got 16 torr, here also 16 torr. Answer. 16 torr spacing. I'll tell you why I am telling all this. 16 torr spacing. We are going to complete these questions, so that tomorrow no one should tell he left a question halfway in between. 131 point something. 131 point something. Okay. Go for 16 torr at 130. Okay. Anyway, later what we will do is, so later this steel will be 16 torr at 130 for us. Why I am told? Because who knows, you may get some other practical question. Heavy distance here, small distance. 25 torr at 100, you may get 16 torr at 200. Yes. Then what people will do? They will take 25 torr 100, alternate bars, they will continue, and if it is sufficient, they will stop. Or if extra required, in between, they will put small diameter bars. And that all I will tell you briefly, not now. When you go to result by ETABS&SAFE, there I will tell detailing part. This is only structural knowledge class. Okay, now, lengthwise bending over, don't forget now, this spacing is how much? I remember, see, I write here now, so that later you will not tell 16 torr at, for here, 16 torr at 115. This is for this bending moment, 16 torr at 130, time being. Okay, now, check for one-way shear. Now remember, Excel sheets, Mr. Nandakumar is there, I think, so no problem. If he is there, nothing to worry by Excel sheet. Okay. And check for one-way shear. Now I am not explaining what is one-way shear, what is two-way shear. Sorry, now too late. If someone will ask, sir, what is one-way shear? No, zero-way shear. There is a limit for explaining. Start. Critical section at D from face of the column. Face of column. Start. Correctly, see now, you put a lengthwise sketch. Just to understand, lengthwise sketch. One column is here. One more column is, see, this column has got larger side. See, this column is 500. Remember, this is 500 millimeter. This column is turned. Here, this column is only 200. See the sketch there, 200. And UDL is acting here. Luckily, UDL, no question of confusion here. How much? 390.625 kilonewton per meter. Now, what you do is, from here, either side, you move by critical section D. One critical section will come here. One critical section comes here. One more critical section will come here. One more critical will come here. I will do one thing now. I will call 1 to understand. 1 dash, 1. I will call this as 2, or I will do one thing. This is left column. I will call this as column 1 and column 2. Okay, now, for column 1, this I will call 1 dash, this I will call 1 double dash. For column 2, I will call this critical section 2 dash, this is 2 double dash. Tell the answer. Correctly tell what is this distance and what is, I want distance from here, this distance. Then tell what is this distance and what is this distance. Tell why you want it. We are learning basic design useful for software later. So later when you go to SAFE, to get the shear force here all, you should start from measurement here. As I tell you, tell the answer now. Don't delay. 1.2 minus 0.5 by 2 minus, where is D? I forgot D value. What is D value? So fast I forgot. 600 and, yes, if I ask you, tomorrow you will give. Is it 637.5 D value? Is it 637.5 D value? Is D value, yes, okay. Now, see correctly, these all explained so thoroughly earlier. Now I should not waste time. See, start. I want from here to here is, or 1 minute now. Everything I want distances here. Why? So that I will explain once again later. See, start. This distance. 2 minus half of 0.5 minus 0.6375. Answer. 2 up to center minus half of 0.5 minus 0.6375. Fast answer. Keep on giving me answer. 2 minus half of 0.5 minus 0.6375. 1.1125 meter. And here, see, 2 plus half of 0.5 plus 0.6375. This distance. 2 from here to here is 2. 2 plus half of 0.5 plus 0.6375. Anybody telling not clear, that means he is absent for earlier classes. Those who are present for all the classes, you should tell, sir, this is nothing. Now you are expert in this one. You should tell that way. I am now expert in all these. First of all, you should tell, don't waste time explaining all these repeatedly again and again. How many times you explain? 2.8875. 2.8875. See, even the pen is little light. Okay, sufficient. No. This distance, tell the answer. 2 plus 2.5 will give you from here to here minus half of 0.2 minus 0.6375. 2 up to center plus 2.5 up to here. So 2 plus 2.5 minus 0.2 by 2, not 0.5 by 2, because other side of column is this way. Minus 0.2 by 2, then again minus 0.6375. Fast. That will give that distance. I will tell you, see, if it is a pure RCC design for without software, then I will find shear force from that side. No, you should be in a position to get the shear force by software. Okay, start. This is 3.7625. Lastly, from here up to here, 2 plus 2.5 plus half of 0.2 plus 0.6375. All the four critical section distances we are getting from left hand. Now see, I will tell you factor shear force per shear force. Fast answer. 5.2375. Okay. 5.2375. Now see, correctly what I want is directly I'll use a color here, blue color. I want factored shear force VU here for 1 meter strip. Okay, answer. Here also, what is that VU for 1 meter strip? I want VU for 1 meter strip, VU for 1 meter strip. See, I will do one thing. Now do one thing. You write a note here. To get that value, if you are going for, here what you do is, first you find shear force here, shear force here, shear force here, shear force here, from seeing the loading diagram. Then, whatever shear force you get, without forgetting, divide by 3.25. Why? Because these are all the values for full width of footing. We want per meter strip. So divide by 3.25. But that is for working load. Multiply by 1.5, you get the value. See what I am doing now. That's all. First of all, 1 minute. When instead of UDL, when it is trapezium, when I solved so systematically, when it is a UDL, if you cannot get the answer, you are not fit for structural design. When it is uniformly varying, there you know how to get the answer. And UDL, if you don't get, means it is like what? It becomes nonsense then. Okay. Anyway, nobody can complain, not explain. Go back earlier. See, here, if I do shear force here, it will come 390.625. I will store that number. Why? It is coming every day now. Store A. Okay. Shift store A equal to into 1.1125 is my shear force display for as per this diagram. But that is the shear force for full 3.25. I will divide by 3.25. I will get for meter strip. I will get for meter strip for working load. I will multiply by 1.5. I will get 200.576. I will get 200.6 kilonewton. That way, here, it is shear force is shift store A, that is 390.625 into 2.8875, then minus 1300. Because why? The moment you go after A, the downward load will come. That is the display. Then I will divide by 3.25 and multiply by 1.5. 79.4. Lesser. Why? Because you can make out here. See, high shear force here, lesser shear force. 79.4, this value. And this shear force, .390 point something into 3.7625, then minus 1300. Now I will convert it to meter strip and factored. Divided by 3.25 into 1.5. 78.4. 78.3 kilonewton. Shear force here, little bigger will come. That is shift store A, recall A into 5.2375 minus 1300, also minus 1200. And then divided by 3.25 into 1.5. 209 point, correct? Huh? That is 2 meter. This is 1.9 meter. Huh? Yes. See, 209.6. Can you tell me why I got doubt? Tell me. Suddenly, see, I told structural, this is called structural common sense. When I looked here, see, Here, this side shear force is 781. This side shear force is 742. So, this side is slightly, earlier question solved. See, inside was critical, outside was lesser. Now reverse. Outside critical, inside lesser. Why? Overhangs are more. Here, high shear force, lesser, little lesser. But I got here 200, I got 209 there. So, it is not correct. Suddenly, when I looked here, I got shock. Not shock actually. Why? Yes, I got the answer. Because, reason. Even though shear force is lesser here column side is 200. So, critical section is near to the column center. From column center, for critical section, nearby, because here you move by 0.5 by 2. Therefore, that is the reason why it came little more. Anyway, now make a note. Make a note. These are the factored shear force you got thoroughly explained earlier in case of earlier question. So anybody new, you have to go back to other classes and learn. Okay. Now, make a note. First of all these classes are meant for ETABS&SAFE batch. I made, but I am taking the class in YouTube live for to benefit anybody who can use it. So, but purpose is for ETABS&SAFE. When you do project or when you go for ETABS&SAFE, none of this one. See, you don't do anything. You don't calculate AST required. Your software will give it. And punching shear, you don't do it. Pressure calculation, nothing. Loading diagram, nothing. Then that into 1.5 divided by this one, that one, nothing. Prepare the model, place the column, run. It will give you steel, it will check for punching, but check for shear, software will not do. So, you require factored shear force here. Tell what you have to do. And ETABS&SAFE will give directly factored shear force for meter strip. It will directly give blue color value. That conversion all not there. Therefore, move the cursor to 1.1125. Exactly not possible. Slight variation. You can see the number there, 200.6. Move it here. You can see 79.4. Move it here by distance here. Because when you move the cursor along the length, measurement of distance should be from here. 3.7625. This number will come. Move it here, that number will come. Okay, start. Now, first, consider under column A, under column 1, tell me, either side shear force is one side 200, one side 79. Tell the answer. What is the VU critical? Fast. What is the VU critical? Under column 1, you don't check for both. Check for only one of them. Actually, remember, this point is actually somewhere here only. This is exaggerated. It is somewhere very nearby. This is exaggerated here. Tell the VU critical. How much critical? Under left column, critical. 200.6. 200.6 kilonewton. Okay, kilonewton. And per meter strip. And there, your AST provided is, how much I told? See, 16 torque at 115, center to center. And FCK is 30. Clear cover is 50 mm. Okay, start. Over. Over. Yes, Nanda Kumar. Use Excel. Those who want to do manual, those who want to use manual, P tau V, PT, tau C, this one, that one, IS code, interpolation, etc., etc. Tell me, verdict, safe or unsafe? Verdict. Verdict, safe or unsafe? Verdict. I want Excel verdict, Tirmana. Court verdict. Verdict means what? Tirmana. What Excel will tell? Safe or unsafe? Type VU 206.6, AST 16 torque 115, FCK 30, clear cover 50. Tell What Excel is telling? What Excel is telling? Safe or unsafe? Why? Excel not ready? Fast. Excel should be ready with you. Those who want do manual, someone will tell, sir, not clear, what to do? What to do means do nothing. What to do means do nothing. See, it's very harsh word from a teacher. Yes, I should tell that way. So much explained earlier, how to check for shear, step by step explained. Then I told, project purpose, we are using Excel. So then I will tell, do nothing. Or leave the class. Safe. Okay, thank you. Verdict is safe. Tell me, tau e value for those who want to check it. Tau e value. Okay, safe, thank you. For those who are checking, tau e value. Excel gave tau e value. You can, when you see safe there, you can see tau e, tau c values. Tell fast. What is the tau e value Excel is telling? Is this much difficulty? What tau e value Excel is giving? Why? Your Excel is not giving? It will give, I told display should be there to understand how much is critical or a 0.321. 0.321. Unit I am not writing. What is tau c it gives? What the tau c Excel gives? Tau c Excel gives. Because if it is very, very narrowly unsafe, better provide little more steel. See, 16 torret 115, make it 16 torret 100 then. See, because we do not want very critical level. 0.424. Okay, thank you. That is, and what is the number displayed there? Tell me, what is the number displayed there? That number. Is it 0.757? That is only 75%. See, that is whatever strength is there, only 75% used, still around 25% reserve strength is there. Is the number 0.754? 0.758? Aitu. 758. That is what? That is nearly 3/4 strength used, still quarter strength is remaining. Good. Okay, over. Now, check under column 2. Type the VU value, how much? 209.6. And change 16 tor to how much? Spacing 16 torret. Where is spacing item? 16 torret. Where? 130 center. Later this is also going to be 115 only. But checking purpose. Now, tell safe or not. Tell me safe or not. Now, fast. Change the value. See, if Excel is there, how fast you can do it. Change the previous shear post to 209.6. 16 tor spacing, change it to 130. I think still safe. Safe. Okay. Tell the answer. What is tau e, tau c? What is tau e, tau c? Tau e. Okay, safe, no doubt. Tau e. See, the Excel sheet very powerful for software, because when you do later ETABS&SAFE, I will not explain again and again. I told you, you should refer the class earlier. Be ready. 0.326. And tau c value. Tau c value. .399. Okay. Safe. Now margin of safety may be around 20% only. Okay. Finally, what we will do is, we will change 16 tor 115, 16 tor 130, both of them we will make 16 tor 100 or maybe 20 tor at 150. That will change later. Okay, now lengthwise bending is clear. Now including check for everything is over. Now the last part remaining. Tell me, if possible, what is the last part remaining? See, now earlier 2 questions, that last part was found to be not that much effective. Now it is little effective. Tell what is last part. Again I will not explain. Last part remaining. Widthwise bending. Those who want to make a note, I am dictating now. I cannot write each and everything. Why? First question over. First question systematically over. Second question over. Now you are right. When you apply the 2 column load, it will have lengthwise bending. Okay, that is taken care. But when you apply the load, not everywhere near the column, either side, some portion will undergo widthwise bending. So that is, see, consider widthwise bending. You put the plan once again. Little plan here, okay, little bigger. Hope space there is no problem. 1 minute. Okay, this is the plan. 1 minute. I should check the space. Oh, no problem. One of the column is here. It is this way. Other column in the same line is this way. See, this way. Okay. Now, whatever is there, from center of the column to either side, usually by a distance d, small d. Later we'll make capital D. This portion and here also, either side from center, this distance not required now, it is required for detailing purpose. This width, there is every chance that it will undergo widthwise bending. Now, what I will do is, I will take a section here. See, I will take a section here. This section I will call 1, 1. This section I will call 2, 2. 2, 2. If the space is there, no problem. I will check the space. I will write both the sketches there. No, that space is not there. So I should, to understand that one, space, no, leave it now. I want compactly to understand. No one should tell later, clear or not clear. Okay, D, you go there. I will remove 3.25. Okay. See, this is 3.25. Okay, now, this is the plan. Okay, I can have the space now. Enough. Let lesser. There is one column here. One more column here. From the center of the column up to some distance, up to where it will come in detailing. This portion and also this portion. I have shown last time for you, this will undergo widthwise bending like this way. First of all, third time I am telling, this way. So, you take a section 1, 1 here and look from this side. Take a section 2, 2 here and look from this side. If I cut 1, 1, look from here, you can see the column like this. You can see this column, short column, and projection is more here. Projection is more. Tell me, this is your section 1, 1. Tell me what is this projection and what is this projection. Little out of scale. Okay. Tell me the 2 projections. Fast. Tell me what are the projection on either side. From 3.25, subtract 0.3, divide by 2. 3.25, subtract 0.3, divide by 2. If you are doing software, you don't have to do this one. Tell what you have to do. All you have to do is, in the model, you draw a strip here. See now, you consider 1 meter strip. See, this is the 1 meter strip considered. 1 meter strip. Here also, not, this is how much length you require it. Now consider, somewhere in that bending region, 1 meter strip. So, now, this is your UDL. Tell me answer. From 3.25, subtract 0.3, divide by 2, you get either projection. 1.475 meter. 475 meter. 1.475 meter there. 1.475 meter here. And this pressure is, since you take 1 meter strip, we want the upward pressure in kilonewton per meter square. Thousands of times I told. If you use the full width, then you require in kilonewton per meter. But when you take meter strip, you require in kilonewton per meter square. Rain completely stopped for this reason. So that is nothing but your net pressure only. See, net pressure into 3.25 gave you 390.625. 390.625 is for meter strip. No, for full width. Tell how much it is. What is the pressure? 100 and net pressure. That net pressure, when you multiply by 3.25, you got this 390.625. If you go for software, you don't have to worry all these things. Prepare a strip there, prepare a strip here, see the result. Chapter closed. But if someone will do that way, if he does not know all these things, he will not be called a structure engineer. He does not know anything. He is simply someone told, you see the result there, okay? That steel you put here. Why you put that way? Tell me, what is the net upward pressure? 100 and this also I told, we want load in kilonewton per meter square. Why? Because you are taking 1 meter strip. You are not giving answer. Net pressure is done in the beginning only. That net pressure only, when you multiply by 3.25, you got 390.625. See, one value you are not giving. Not audible? Audible. I don't know why it's happening. 120.2. Don't tell wrong things. It is 120. I'll write somewhere here. Space problem. This is 120.2 kilonewton per meter square. Now, this is a cantilever. This is a cantilever. This will bend like this. This will bend like this. You require bottom steel. That bottom steel will come here. See, in the plan, bottom steel will come here. Okay, now, this is section 1.1. Tell the answer now. For section 1.1, what is the maximum BM? Where? At the face of the column. Column equal to 120.2 into 1.475 into 1.475 by 2. Answer. W into this length into length by 2. UDL. If it is UVL, to area into A plus 2B into A. See how much you struggled last time. This time simply 120.2 into 1.475 is the total load into 1.475 by 2 will give the bending moment. How much bending moment? Okay, 120.2 will do. Now you should not tell. After half an hour, you are telling 120.192. 130.8. It is 130.8 kilonewton meter sagging. Now, therefore, tell what is MU. Factor, this is for working load. Working load for 1 meter strip. So, factored value 130.8 into 1.5. Answer. 10 to the power kilonewton meter will come. What is the factored BM? Into 1.5. Little fast. 196.2. Okay. 196.2. Now, be careful for widthwise bending. If you take 25 torr not required because lesser bending moment. Suppose you take 20 torr. Take 20 torr. Later, if you want or 25 torr only, you can take or do one thing. Take 25 torr only. Why? Sometime it becomes why safer side. Why I told you safer side 25 torr. Later, if you go for 12 torr, good. Okay, 25 torr only. Your D will be 700 minus 50 minus 25 minus 25 by 2. Why I told you? After placing lengthwise bar, above that widthwise bars are placed. So D for widthwise bar will be same as lengthwise bar, one full diameter and half diameter. Sorry, further I am not explaining. Why? If you, first of all, if I explain, you should protest and leave the class. You should tell, sir, it's already told earlier very clearly. Why you are wasting time? D. What is the D value? Now also D did not come. D will change. You are wasting a lot of time to give D value. See, 25 torr I have taken for safer side. Later you give lesser diameter. That is D will be more. 612.5. Okay. With that 612.5 mm D, what is MU limit? 0.36 into XU max by D into bracket 1 minus 0.42 into XU max by D into width is 1000, D square is 612.5 square into FCK is 30. This will give in Newton millimeter. Tell me what is the MU limit in kilonewton meter. This you will not tell. You will take one full day. I will calculate. 0.36 into X max by D into bracket 1 minus 0.42 into X max by D into 1000 into 612.5 square into 30. 1 divided by 10 to the power 6. 1503.7. 1503. 1603. 1503.7. 1503.7. Therefore, your MU is less than MU limit. Okay. Lastly, AST required. Tell the answer. Substitute in the basic equation MU 130.8. Bending is how much? 196.2 adu 196.2 10 to the power 6 equal to 0.87 into 500 into AST into D is 612.5 into bracket 1 minus AST into 612.5 divided by AST into FY. FY is 500 divided by B is 1000. D is 612.5 divided by FCK is 30. Solve the quadratic equation and tell what is the AST required. Tell what is the AST required in mm square. Minimum remains same as last time. Actually, slight change will come because D changes. That's all, we will not bother. How much that minimum? I forgot. That minimum, if I ask you, you will tell tomorrow. So I better go backwards and check that minimum. Otherwise, it will take half an hour for you to search and tell me. L is the minimum. Minimum we decided. I rubbed it. 1080. We decided minimum 1080. Okay. Actually, if we change the D value to lesser, minimum will come lesser, safer side. Now tell me. So I went to the class earlier. Again I come back live now. Okay. Answer first. AST 751.7, 752. AST is 752 mm square, which is less than minimum. See, minimum is 1080. Therefore, provide 1080. Now, low steel, what do you do? 25 torr spacing. Tell the answer. Somebody will laugh now. 25 torr spacing. Very high spacing will come. Some will tell no, this much of high spacing is not allowed. Tell me, 25 torr spacing. It is 491 by 1080 into 1000. Is it divided by 1100 into 1000? Is it 454.6? Is it 454.6? Spacing. Is it 454.6? 25 torr spacing. No, something wrong I think. I'll check once again. 25 torr spacing is pi by 4 of 25 square divided by 1080 into 1000. Correct, 454.5, correct. Correct actually, 454.5 it came. This is very high spacing. Do one thing, come down. 16 torr spacing. Come down to 16 torr. Spacing will come. This is not calculator, it is mobile. pi by 4 of 16 square divided by 1080 into 1000 is 186 point something. Okay, done. We will provide 16 torr at 175 center to center. Okay, done. Clear? Fast. 60. Last time question solved, widthwise bending was less. See now, by chance in any footing, due to length restriction, if width becomes more and more, sometime it is possible that lengthwise bending is lesser, whereas widthwise bending is more. Then you need high steel for widthwise. Accordingly, you provide. Now, what you have to do is, if you take a strip here, when you move the strip here, it will show you steel of how much? 752 mm square. And then you decide minimum and provide. Now, clear? Fast. Clear or not? Tell me fast, clear or not? We are coming to closing part of this one. If you tell clear, I will go to last column. Then little more writing is there, that's all. Clear? Okay. Now do one thing. Repeat the procedure for column 2-2. 2-2. The only change is actually not required. Tell why. See, but why I am telling required? Because some will tell, sir, here projection is more, here projection is lesser. So not required. Yes, correct. Because UDL is acting. But by chance, high pressure comes there, low pressure comes here. Then even if projection is more, because of low pressure, bending will be lesser. There, even if projection is lesser, because of high pressure, bending can be more. So since you are learning for practical, do everything. Section 2-2 means, now you can see the column, see, you cut here, then you can see column side, now 500. Now tell what is the answer here, fast. You see, now you are seeing column side of 500, then 3.25 minus 0.5, not 500, sorry, 600. 3.25 minus 0.6 divided by 2, answer. 3.25 minus 0.6 divided by 2, projection. How much projection? 3.25 minus 0.6 divided by 2, 1.375. It comes to 1.375 meter, 1.375 meter. Now, can you repeat all this calculation now? Instead of last time 1.475, now change to 1.375. And remember, now also steel will come less than minimum, therefore provide minimum only. Can you calculate bending moment and repeat the AST calculation? Just for information, I want the answer. Why? Today it came minimum, tomorrow it may not come minimum, it may come more. So when you learn, you should not tell, sir, it is lesser, sir, today lesser, tomorrow we don't know. So clear now? Now fast. Can you do it? Change that 1.475 to 1.325. MU limit is not required. Why? D is same. Tell me fast. If you can repeat, I will just take 5 minutes break and come back and go for the closing part. 1.325. Okay. Can you repeat? Bending moment, factored value and AST required. Can you do it? Tell me what is the bending moment, what is factored value, what is the AST required. Can you do that much? First. If you can do that much, by that time 5 minutes I will come back here. Yes, start. And tell me, it will take 5 minutes for me. And then I will go to the concluding part of this combined footing. Okay, start. Don't waste time. Okay, I got the answer. It is correct. I can make out. Here AST is how much? There AST came 752. Now for this one, I write the answer here. Your AST required will come. Okay, your bending moment M will come. Lesser value. Someone typed the answer. Looks like correct. 113.6, which will give MU equal to 170.5. And AST required will come 651.3. 1.3 less than minimum. So here also provide 16 torque at same 175 center to center. Over. See, now combined putting of slab type with all design parameters are over. Now what I will do is detailing part. More and more will come in the software later. But even then, there will be detailing for all these three, up to where you have to take the bar, where to stop the bar, where you put extra bar, top steel how much you have to give, those things I will explain. Then combined putting of beam and slab type. I told you that is actually nowadays it is outdated. I inquired. People tell, sir, no sir, nowadays you are not going for it. Still, it is possible you can go for it. Then design principle will change. I will tell the design principle so that when you go to ETABS&SAFE, slab will have widthwise bending, beam will have lengthwise bending, how to do it, and there for the beam, shear reinforcement will come. That software will do, you know, how to design shear reinforcement. VU, then spacing equal to 0.87, tau V will come more than tau C. There shear reinforcement required, sometime 4-legged or 6-legged will come. And then there also detailing part. Then raft footing, manually not possible because highly complication. We have to go to lot of approximation. So if raft footing is there, how to decide the bending pattern, how you provide reinforcement, and what you have to do for raft footing, that also will come. All this will come tomorrow's class. Because detailing part, there is a problem. I have to be liberal. I do not want to be liberal in public. Public, I do not want to be liberal. I told exact requirement. But those who are in the batch, for them I will tell, because why? They are accepting me. Whatever I tell, they are going to believe it. Public, some comment may come tomorrow. He is putting more steel there, not required. I can give lesser steel. He can give, but safety comes. Therefore, all that I will tell in the next class, that is tomorrow's class, will be the last class for your structural design. Tomorrow will be the last class for structural design part or pre-requirement or basic knowledge part. Immediate next will be software. Then in the software also design will come. At that time, we will not do all these things. See, usually what we will do is, what example we have taken in this class, we will try to make model for the same. When I go to combined putting, I will tell you, see, 3.25, 6.4, place the column, run a strip, see the AST. I will tell you, tell me earlier what AST came. Slight fluctuation will be there. Punching shear, number will come. Shear, that you have to do by Excel. See, I told you, move the cursor along the length, decide the shear. Or beam design. See, you know how to design the beam. Beam, slab design, one-way slab, two-way slab, all you have done. That all I will do in the software. See, in the software, today I am putting a brochure because some people, they asked, they want to come only for software. They told, structural knowledge, we know everything. They told, we know everything. See, I told, okay, no problem. You know everything. But inside me, I know what they are knowing. Then, those who join, they are bound to ask, sir, when you move the cursor here, why it gives shear post? How you got it? I will tell, you know structures, everything. You should know these things. No, that I am not knowing. Then you told you know everything. You wanted only software. If it is only software, you don't have to worry too much. You should know correctly how to prepare the model and how to draw the strips and take out the result. That's all. But if something goes wrong, see, just now, shear post here and shear post there, I had a slight doubt. I looked here, my doubt clarified. Suppose imagine this column also same dimension, and if it gives higher shear here, I will be knowing wrong. But it will be correct if pressure is more there. So that all naturally will come only if you got basic structural knowledge. So what we will do in the software class is, after going through all the, I will explain more tomorrow, after going through all the basic of the ETABS, that is global, local, coordinate, long back told, I will repeat, then create the point, how to create the beam, how to give section property, and then how to activate load combination, how to assign different loads, how to create the floor slab in different floors by copying, shifting all up. After all those things, I will go for beam design. I will tell a beam of span 6 meters, loaded by so and so, design. What you will do is, prepare the model, design. But side by side, previous day, in a paper, I will write analytical solution and send to you. This is already known for you. This is which is already covered here in the class. So then I will tell the number, the notes I sent, what is the number? You will tell, sir, 899.6 mm square is the bottom number. Software will give same number. Maybe 898, 900, it will give same number. Then you get confidence. Then one beam with the overhangs also will do. See? Then see why hogging, sagging, both are there. Then after that one continuous beam will design independently. There, that hogging, sagging, reinforcement, detailing, I am not told, I will tell in the class. Up to, see, you have to extend the top bar by how much distance, bottom bar up to where you have to extend, practical requirement. Then column, we designed a column in the class. I will prepare the same model there. Or if any difficulty is there, I will create a new question, and in the paper I will give you this is a question. Those who want can do manual design. Footing, what footing we did, same footing we will create there, and what result we got manually here or basic knowledge, we will check the result there. Once all those, they are called independent design. I told in the, see, tomorrow, today night or tomorrow, I am going to putting a one demo class like that for the newcomers. There I will tell an example. Why you want independent? We came for project. Why do not independent? See, example I told. If you want to drive a car, you cannot sit in the car and drive. During driving, that is gear. Then this is clutch. This is accelerator. This is brake. This is ignition. No. If you want to drive smoothly, or if you want to do the project very smoothly, then before driving, you should know correctly where is the brake, where is the accelerator, where is the clutch, where is the steering, how much you have to turn, ignition is where, all those you should know, where is the battery, etc. Everything you know, even how to lock the car, you should know it. They are independent. You cannot drive and tell, someone came, hey, apply brake, 1 minute, brake, accelerator, clutch, brake, 1 minute, let me see, doubt now. This is accelerator. This is brake, I think. Open a kit. Oh, from right side, second is brake. Can you do that way? See, when you drive, so many good drivers, they don't know change of gear. Why? They will be talking and naturally they will do it. They are used to it. That is called fluency. That fluency you should have before you start preparing the model. So I allotted around 80 hours for further. So total I told 150 hours. I know some will tell, sir, 150 hours already over. If already over, remember, I am losing. You are not losing. You are gaining. Because what I committed, it is more, means you are gaining. You are not losing. So therefore, around 80 hours. There, two parts are there. One part will be basic of the software with the independent knowledge. Then you become expert in driving. Then take the car. Then you don't ask somebody, accelerator is where. You will automatically know where is the accelerator, etc. Then when you go to project, when you prepare a model, you know correctly, oh, this steel, top steel, bottom steel, footing, yes, everything is known. Why? Because of all these independent design examples. So software also, I will not go to manual design now onwards. Everything will be software there only, except tomorrow's class. No more manual explanation. But what will happen is, there fluency required. The purpose is what? See, a good designer should have solid structural background. That I think all these classes I have given as much as possible. Are you agreeing? Reasonably good knowledge I have given. Yes or no? I have given reasonably good knowledge. Are you agreeing or not? Not from today. See, those who are public, they joined recently. Right from the class 1 of ETABS&SAFE. Right from class 1 of ETABS&SAFE. All that working stress, that principle of bending, shear, etc. Everything told so far systematically. So then only he will become a good structure engineer. Now, tomorrow's class, what you have to do is, see, there are 3 combined footing we solved. I will ask you question, you should tell. See, today's class you have to tell. Depth of slab is 700. Don't change tomorrow. Then, width of footing, 3.25. Length of footing, when I ask you, 6.4. Column side, 300 by 500, 200 by 600. 2 meter, 1.9, 2.5. Lengthwise bending steel, only bottom steel. Left side bottom, 16 torr 115. At right side, 16 torr 130. Lateral widthwise steel, you should tell both the columns, 16 torr 175. That is for today's question. Same way for your question 1 and 2, you should prepare everything. Get ready tomorrow. Agreed? You should refer the class and tell me same way. See, earlier questions, it was sagging, hogging and sagging. Here bottom tail, here top tail, here bottom tail. We finalized in the class. You should tell immediately. Then I will go for adjustment. I will tell that way you cannot give. Little liberal you have to go for. I will tell how to give liberally. But I want right first what is the requirement. That in public I don't want. I want that information only for the people who are in the group. Clear? All the 3 questions. You should give data immediately. Today only do one thing. 3 questions solved. First question, what is the width, what is the length, and then thickness, how much bottom steel here, how much bottom steel here, final answer, how much top steel here. Widthwise, what is the steel? That way, for all 3 questions, little fast you have to give. And tomorrow's class will not be in YouTube, it will be back in Zoom. Tomorrow class will be once again in Zoom only. So Zoom means one advantage is there. If it rains heavily by chance, nothing to worry, I can pause. I can pause. Here no, I cannot pause. Actually, I can pause in YouTube. For that, you have to take YouTube class through app. There is an app is there. First of all, this only I am managing with difficulty. If I use app, then in the app, pause option is there. Here if I pause, suddenly gets disconnected. Then I have to start a new class tomorrow. Then once again, I have to use the new link. So tomorrow onwards, class will be in Zoom once again. So in the Zoom only, so there is, if it by chance, today there is no rain today. So by chance it rains, nothing to worry. Why? We will pause for some time. When it is horrible there, we will pause for some time. And YouTube means what? Public. Disturbance more means does not look like. Zoom only you are seeing. As long as my voice is clear, it is sufficient for you. The decoration is not required for Zoom class. Okay, so tomorrow class will be in Zoom only. As usual, I will not send YouTube link now. See, you will get the link in the group for Zoom only for ETABS&SAFE batch and also for RCC batch for tomorrow. Also for RCC batch tomorrow. From next week onwards, only for ETAB batch. Because why? Once again, software part you are doing. Okay, now I will conclude the class now. All I told for you today, what I require tomorrow, get ready information. Like I told you, reinforcement. Do not waste time tomorrow. Do not waste time. There is no lag. As I ask slab thickness, correctly I will tell, not one question data for other question. 3 questions you make a note today and get everything ready. Tomorrow link will come in the Zoom class, Zoom only. So I hereby tell goodbye to all the people who are new people or general public who are watching through YouTube. That is those who are not in the group. This information I given, use whatever I given, at least use that much information. Don't tell, I want the detailing also. No. There is a limitation is there. General public class will end today. Tomorrow onwards, back to Zoom. Okay, thank you. We will meet tomorrow in the Zoom class only. Okay, thank you.